Welcome to Scientific Notation Multiplying and Dividing. Before we get going, just want to recall that when you multiply a number by a power of 10 that has a positive exponent, you're multiplying by a very big number and you'll have an overall very big number. When multiplying it by a power of 10 with a negative exponent, you are multiplying by a very small number, and so your overall number will be very small as well. To multiply and divide today, we need to review how to multiply and divide powers. Looking at the first example, 5 squared times 5 to the fourth. If you remember in expanded form, 5 squared is 5 times 5, and then if we multiply that by 4 more 5s, we have a total of 5 to the 6th power. And if you recall, that means that we could really have just added the exponents to begin to get 5 to the 6th power. So using this rule again, if we look at 17 to the 30th power times 17 to the 13th power, that really is going to be a total of 17 to the 30 plus 13, which gets us a total of 17 to the 43rd power. In our last example, looking at the division, instead of adding our exponents when we were multiplying bases, we're going to subtract our exponents because we are dividing bases. So this problem becomes 8 to the 6th minus a negative 2, which a subtraction of a negative means adding a positive, and that gets us 8 to the 8th power. A few things to anticipate today. We are going to use the commutative property of multiplication to rearrange numbers and multiply the leading numbers together, as well as the powers. And then we'll also need to look to express our answer in scientific notation. Looking at our first example here, we have 2 1/10 times 10 to the negative 3rd power times 3 times 10 to the negative 9th. Using the commutative property of multiplication, we can go ahead and regroup our leading coefficients or constants and do 2.1 times 3. And multiplying and using the same approach, group the powers and multiply 10 to the negative 3rd times 10 to the negative 9th. Now we simplify. 2.1 times 3 is 6.3 or 6 3/10, and multiplying by the powers of 10, they have the same base. We can go ahead and add the exponents. And so our final power is 6.3 times 10 to the negative 12th. This is in scientific notation. The first number is between 1 and 10, and the second number is a power of 10. Looking at another example, we have 4 times 10 to the 4th power times 6 times 10 to the negative 2nd power. Just as with the previous example, we'll go ahead and regroup the leading numbers, 4 and 6, and multiply that by the powers of 10 that we have, 10 to the 4th and 10 to the negative 2nd power. Simplifying, we get 4 times 6 is 24, multiplied by the powers of 10, 10 to the 4 plus negative 2, leaves us with 24 times 10 to the 2nd power. However, this number is not in scientific notation. The first number is not between 1 and 10. So let's go ahead and expand this number into standard form so that we can work it back into scientific notation. We have the first number, 24, times 10 to the 2nd power means we're taking the decimal after the 24 and multiplying by 100 or moving it twice to the right. Now we need to get a number between 1 and 10, which if you see it's going to be 2.4. And moving the decimal from where it ended after the 0 back to the 2.4, we moved it 1, 2, 3 times. So now our final power is going to be 2.4 times 10 to the 3rd power. It's a big number, so we keep it a positive exponent, and now our leading number is between 1 and 10. Let's try this just one more time. We have 7.1 times 10 to the negative 8th power times 8 times 10 to the 4th power. Taking our leading numbers, our constants, we get 7.1 groups with the 8, 7 1/10 groups with the 8, and multiply that by the powers of 10 multiplied together. Doing a little mental math here, we get 7.1 times 8 is 56.8, 56 8/10, times 10 to the negative 8 plus 4 is negative 4. This number again is not written in scientific notation. The constant is greater than 10, so let's go ahead and expand it in order to get it back into scientific notation. Taking our leading number, we have 56 8/10, 56.8. The negative on the exponent tells us that we are getting a small number, so we take the decimal where it is, and we'll move it 1, 2, 3, 4 times to the right. And now we need to get it back so that we have a number between 1 and 10. I hope that you guys see it's going to be the 5.68. And so going from where I ended before the 0, I'll have to move back 1, 2, just 3 times to get the 5.68. So our final answer written in scientific notation, we have the number now between 1 and 10 times 10 to the third power as we move the decimal 3 times. Because it is a small number, a decimal, we do have that it is a negative exponent. Now let's look at a couple of examples of division. We have 18 times 10 to the 18th divided by 3 times 10 to the 6th. Just as with multiplication we group the constants, we're going to go ahead and do that here. 18 divided by 3. And again, just like with our multiplication, we're going to go ahead and group the powers of 10 and divide those separately. And so, if we divide 18 and 3, we get 6 times. If we subtract the exponents now on the powers of 10, as we are dividing, we will get 18 minus 6 is 12. So our final number written in scientific notation, 6 times 10 to the 12th, the first number is between 1 and 10, and we are multiplying by a power of 10. Let's do it again. We have 30 times 10 to the negative 5th divided by 2 times 10 to the negative 8th. Grouping our first two numbers, our constants, we get 30 divided by 2 is 15. And when we are multiplying by our powers of 10 grouped together, we have 10 to the negative 5th divided by 10 to the negative 8th. And remember, with division of powers with the same base, we'll go ahead and subtract the exponents. Subtracting a negative 8 is the same as adding a positive 8, and so we'll get 15 times 10 to the third power. However, this is not in scientific notation. The first number is greater than 10, and so we'll go ahead and take that 15, bring it out to the side, multiply it by 10 to the third power, which means we're moving the decimal after the 15 3 places to the right. And to get that number between 1 and 10, we do want it to be 1.5. And so taking it from behind the 0 to the 1.5, we move 1, 2, 3, 4 places. And so our final power is 1.5. That's the number between 1 and 10. Times 10 to the fourth power. It stays positive as we have a big number. And just one more time. 5 times 10 to the fourth divided by 8 times 10 to the ninth. Just looking at this fraction, I hope you see that a smaller number on top divided by a bigger number on the bottom means we're going to have a small number. And so let's go ahead and group. 5 divided by 8 leaves us with 0.675. And multiplying that by the powers of 10 grouped together, 10 to the fourth divided by 10 to the ninth. Go ahead and subtract those exponents and we'll get 10 to the 4 minus 9 is negative 5. That is our small number. Looking at the first number, we have it that it is less than 1, and so this is not in scientific notation. So we will bring the 0.675, that constant, outside, and we are going to write it into standard form. Because we have a negative 5 on our exponent, we'll move it 1, 2, 3, 4, 5 places to the left to get that small number. And now to get that number between 1 and 10, we need to place that decimal at the 6.75 mark. And so from before the 0 going back to that new decimal point, we move not only the 5, but one more. And so we'll get 6.75 is that number between 1 and 10, times 10 to the 6th power as we move the decimal 6 times. Because it is a small number, we do need that negative exponent.